All right, in this section, we're going to be using sum and difference formulas. So pardon me while I flip around. There they are. All right, so using the packet that I uploaded into Canvas, you will see I conveniently put your sum or difference identities on page 2 of your packet. And so I've got sum or difference identities for sine, for cosine, and tangent. Well, where are the other ones? It's just going to be 1 over sine for cosecant. It's going to be 1 over cosine for secant, or 1 over tangent for cotangent. So let's look at how to read this thing first. What I have here is the sine. These are Greek letters, alpha and beta. And so I've got the sine of alpha plus beta. So remember, the argument of a trig function is an angle. So I'm adding 2 angles together, or I'm subtracting 2 angles together. So it's important to look at the identity, but it's also important to see that this addition sign is on the top of the plus minus. So look at what's on the top over here. There's an addition sign on the top over here. So let's look at that for cosine. Cosine of alpha plus beta, your plus is on top. So when you come over here, your minus is on top. So if you're adding 2 angles together for cosine of alpha plus beta, you're going to end up using subtraction in the identity. So whatever operation is on top is what you carry through. Whatever operation is on bottom is what you carry through. And then tangent is the ratio of sine to cosine. Or, so that's what this mess is. This is the sine of alpha plus beta, or the sine of alpha minus beta, over the cosine of alpha plus or minus beta. Or we can use tangents here. Okay, so notice this is not a typo. If I'm adding, that's what's on top. So I'll have tangent alpha plus tangent beta over 1 minus, because that's what's on top, tangent alpha tangent beta. Okay, and these can be a little bit overwhelming when we're rationalizing and that type of thing. So what we're going to do first is figure out what our strategy is. So I'm going to start with the cosine of 15 degrees. And I noticed that 15 degrees, first of all, is in quadrant 1. Okay. So the cosine of 15 degrees is in quadrant 1. And what I want to do is identify 2 benchmark angles that I know that when I add them or subtract them, I'll get 15. So I'm betting it's going to be subtraction because our first benchmark angles are 0 and then 30. So just twiddling around in my head, I can do the cosine of 45 minus 30. So I can change this to the cosine of 45 degrees minus 30 degrees, and both of those are benchmark angles, which means I know the ratios. So this is my alpha, and this is my beta. And when I substitute in, what I'm going to look for is I've got cosine of alpha minus beta. So that's going to be the cosine of alpha times the cosine of beta. And then where I'm going to look and make sure, okay, addition, you can't see, addition on top, subtraction is on bottom. So when I follow through, addition is on bottom. So even though it's subtraction here, it's going to be addition here. So I'll have the sine of alpha times the sine of beta. And all I got to do is plop stuff in there. So the cosine of alpha, well, alpha is 45. So the cosine of 45 times the cosine of 30. So cosine alpha, cosine beta, plus sine alpha, so the sine of 45 times the sine of 30. So cosine alpha, cosine beta, plus sine alpha, sine beta. Well, what's the cosine of 45? It is root 2 over 2. What's the cosine of 30? It is root 3 over 2. Plus, what's the sine of 45? It's root 2 over 2. What's the sine of 30? It is 1/2. So you'll notice, holy cow, I've already got a common denominator. It's 4, not 2. Okay, my common denominator is 4, because 2 times 2 is 4, 2 times 2 is 4. So root 2 times root 3 is root 6, and root 2 times 1 is root 2. So that is your answer. You cannot reduce those by 2's. Don't do that, because 4 is outside the radical, and 6 and 2 are inside the radical. So that is the cosine of 15 degrees. Now, try it in your calculator, which you cannot do. I'm just trying to show you something. So if I do, make sure you're in degrees first. If I do the cosine of 15 degrees, I get 0.9659, blah, 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 blah. If I enter this ratio right here, so I'm going to do alpha y equals, and that's, if you've got new software, that's going to give you a little fraction. So I'm going to do the square root of 6 plus the square root of 2, and then I'm going to put that over 4, and I get the exact same answer. Okay, square root of 6 plus the square root of 2, all that quantity over 4 gives me the exact same answer. So this is the formal answer. This is the this is the non-decimal. This is exact. Okay, this is a decimal approximation. So let's try another one. We've got the tangent of 15 degrees. Okay, so we already have the benefit of knowing what my angles are that I can use. So I'm actually going to change this thing into the tangent of 45 minus minus 30. So there's my alpha, and there's my beta. So looking at my formula, the tangent of alpha minus beta, so I'm going to use the signs on the bottom. I'm not going to go through all this mess. I'm just going to come over here. Okay, so I've got tangent alpha. Since I'm doing addition, use the signs that are on top. So I'm going to add, and then down here I'll subtract. So I've got the tangent of alpha plus the tangent of beta over 1 minus tangent alpha tangent beta. And now I've just got to throw these things in and remember what my ratios are and simplify. So tangent alpha becomes tangent 45 plus tangent beta is, ooh, wait a minute, we're doing subtraction. Sorry, so this is minus, holy cow, and this is plus. Okay, sorry, and so this is minus. All right, you're like, that's not what that says. Okay, so I've got tangent 30, and then I've got 1 plus the tangent of 45 times the tangent of 30. Okay, so I had subtraction here. I had it in my head we were adding. So it's going to be subtraction here, addition here. So subtraction here, addition here. So what's the tangent of 45? The tangent of 45 is 1. Minus, what's the tangent of 30? That is root 3 over 3. Over 1 plus, the tangent of 45 is 1, times the tangent of 30 is root 3 over 3. So when I simplify this, what I want to get this down to is just an expression over an expression. Okay, and right now I need to get a common denominator. Okay, so what I have, this is going to be a 3 over 3. So 3 minus root 3 over 3 over. And then 1 times that is going to be root 3 over 3. So this is going to be 3 root 3. That's not 3 root 3. 3 over 3 plus root 3 over 3. So that becomes 3 plus root 3 over 3. So I just changed this into a 3 over 3. Well, now what can I do? I can do a ratio divided by a ratio, means I multiply by the reciprocal. So that's 3 over 3 plus root 3. So those are gone. And my answer is 3 minus root 3 over 3 plus root 3. Okay, now you may have to go a little bit further. So when I go a little bit further, I just want to keep going until I can't go any further, which means I don't like the fact that I've got a radical in the bottom here. Okay, so I am going to multiply by the conjugate. And when I multiply by the conjugate, which is going to be 3 minus root 3, 3 minus root 3. So this is an answer, but it's not proper. Okay, so I'm going to take this and multiply top and bottom by the conjugate, which means I'm really just multiplying by a fancy 1. Okay, so on the bottom, what's the benefit? On the bottom, 3 times 3 is 9. And then minus 3 root 3, plus 3 root 3, and then minus 3, because the 3's will pop out. So that's your denominator. Your numerator is going to be 9 and then minus 3 root 3 minus 3 root 3. So minus 6 root 3, and then plus, so a negative root 3 times a negative root 3 is a positive 3. So when I clean this up, 9 and 3 is 12, minus 6 root 3 over 6. So my 6 is reduced this way, and then it becomes a 2 this way. So remember, that's a 12 over 6 minus a 6 root 3 over 6. So that reduces to 2 minus root 3. That is your answer. So the rationalizing, the actual trig part of it is pretty straightforward and easy. It's the rationalizing that's going to be nasty. All right, so let's try this again. What we have is the sine of 5 pi over 12. And I'm trying to use sum and difference formulas to figure these things out. So basically, I need to figure out what to add and subtract together to give me that answer. And until you get used to it, we're going to kind of refer to the unit circle. So remember that 6 pi's over 12 would be pi over 2. Okay, so 6 pi's over 12 would be pi over 2. So I'm trying to find an angle that's right about in there somewhere. Okay, so I'm in quadrant 1, and I'm just going to keep identifying the quadrants because it's going to help a lot in the next section. Okay, so I need to know, and this is where until you're used to it, you've got to play with it a little bit. If you'll notice, all of your radian measures are factors of 12. All of your radian measures have denominators that are factors of 12. So I might want to try 2 pi over 3 minus pi over 6. Okay, because that looks like it might be kind of sort of close to what I want, but you've just got to play with it some. I may want to add it together. Okay, so what we're going to do first is play with it, and I'm not going to tell you what to put together. You're going to get used to it, so I'm going to intentionally lead you down rabbit trails that don't work. Okay, so let's try 2 pi over 3 minus a pi over 6 first. Okay, so if I need a common denominator, I'm going to multiply top and bottom by 2. So that means I get 4 pi over 3, 4 pi over 6 minus a pi over 6 gives me 3 pi's over 6, which is pi over 2. That didn't work. So what else are we going to try? Okay, so this part is going to be the harder part. So let's try 5 pi over 4. Or sorry, let's try 3 pi over 4. And then, so that's going to be a 9 pi over 12. And then I need to subtract off. So there's my 9 pi over 12. So I just got a common denominator. Well, I need to subtract off 4 pi's over 12. So, good land to Goshen. All right, so that reduces to pi over 3. Okay. So what I'm doing in my head is I'm trying to find something that when I get my denominator of 12, I can then rapidly identify what I need to add or subtract to it to get this answer. So I grabbed 3 pi over 4. I put it in a denominator of 12, so that gave me 9 pi's over 12. Well, now I need to subtract off 4 pi's over 12 to give me 5 pi's over 12. Does that reduce to a benchmark angle? Yes, it does. So that's my strategy. So this is going to end up becoming the sine of 3 pi over 4 minus pi over 3. So that's my alpha, and that's my beta. So alpha and beta. And so if I'm using a sum or difference formula, what I'm going to see is the sine of alpha minus beta is going to be sine alpha cosine beta minus cosine alpha sine beta. So this becomes the sine of alpha cosine beta minus cosine alpha sine beta. Okay, so that means I've got a sine of 3 pi over 4 times the, why do I do that? Times the cosine of pi over 3 minus the cosine of 3 pi over 4 times the sine of pi over 3. Okay, so bringing this forward a little bit. So what's the sine of 3 pi over 4? The sine of 3 pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2 minus the cosine of 3 pi over 4 is negative root 2 over 2. And the sine of pi over 3 is root 3 over 2. So this is going to become plus positive. So I get, remember your common denominator is 4s. So I get over 4. So root 2 times 1 is root 2 plus root 6. So root 2 plus root 6 over 4 is the same value as 5 pi, or gives you the same ratio as the sine of 5 pi over 12, or is the same ratio. Okay, so let's try, actually, let's pause there, and then I'll pick up with the second video.